Hey, fourth graders, it's Miss Seals back for our next science lab. So we are still talking about energy. If you remember last week, we were talking about mechanical energy. This week, we're going to be talking about sound energy. So here's your target. I can differentiate among forms of energy, including sound. Remember that energy is the ability to cause change or do work. And I gave you this acronym of the word MELTS. Each letter is the first letter of a form of energy that we are going to be talking about over the next couple weeks. Last week, we talked about mechanical energy, which hopefully you remember is the energy of motion or movement. We'll be talking about electrical, light, thermal, which is heat, and then this week we're talking about sound. So sound energy is a form of energy that is produced by vibrations. A vibration is when something moves back and forth quickly. So every sound is caused by a vibration. Without a vibration, there will not be a sound. So let me go back. So an example of a vibration is, put your hand right here on your throat and go, ah, or talk or say something. Can you feel something moving? That's a vibration. Inside of your throat are something called vocal cords. And whenever you talk or sing or hum or make noise, they vibrate. They move back and forth very, very quickly. And that pushes the air out of your mouth and creates a sound wave. And that sound wave travels to people's ears and hits goes inside the ear and hits the eardrum and creates another vibration. And that is, that's how we're able to hear sounds. So let's talk about another word that has to do with sound energy, which is the word pitch. Hopefully you remember from last year or maybe from music class that pitch is a word that describes how high or how low a sound is. It doesn't mean loud or quiet. That's another sound word called volume. Pitch is how high or how low a sound is. Fast vibrations cause higher pitched sounds. Slow vibrations cause lower pitched sounds. So I'm going to give you an example of this. I'm going to stop sharing for a minute and come back. I have these things right here called tuning forks. If you've been in the science lab, you have seen these before in previous grade levels. These are not like the types of forks that we eat with. These are tools used by singers or musicians or people who play instruments to tune to the correct pitch. Each one of these tuning forks is a different pitch. The bigger the tuning fork, the slower it's going to vibrate and the lower the pitch is going to be. The smaller the tuning fork, the faster it's going to vibrate and the higher the pitch is going to be. Okay, so I'm going to give you an example of a low pitch and a high pitch. Here's a low pitch. Hopefully you can hear that. And then here's a high pitch. Very high pitch. So do you hear the difference between low pitch and high pitch? It's not loud and quiet, it's pitch. All right, so let's go back to our PowerPoint. So how is sound used in our everyday lives? I want you to take a minute, see what you can come up with. How do we use sound in our everyday lives? How is sound important to us? And when you're ready, come back to this video and I'll show you what I came up with. Here are some ways sound is used in our everyday lives. When we listen to music, when we're listening to our teacher or our classmates, when we hear birds singing or chirping, when we hear a car honk its horn, when we're watching and listening to TV, and when we're having a discussion with friends or classmates or anybody else that we encounter in our day-to-day life that we would like to communicate with. So sound is very, very important. Without it, it would be very difficult to communicate. It would be difficult to hear music or watch TV, anything like that. So today we are going to do some exploration. So today's not really an experiment. It's more of observations and explorations with sound, and specifically vibrations and pitch. The students who are at school will be kind of rotating through some different stations to explore sound and pitch and vibrations. For those of you at home, I'm just going to kind of be showing you. And then all of these are very simple. They don't require a lot of materials. So if you would like to do any of these at home, make sure you have a parent's permission. So the first thing, probably this first one you wouldn't be able to do at home because you probably don't have tuning forks at home. The first thing says we're going to place a pinch of salt on top of a plastic wrapped cup. Then I'm going to hit the tuning fork on the table and touch it to the plastic wrap, and we're going to watch what happens, okay? So here's my plastic wrapped cup. I'm going to add a little bit of salt to the top of this. There we go. Then I'm going to take my tuning fork, I'm going to tap it on the table and touch it to the plastic wrap. So we're watching to see what happens to the salt. Whoa, do you see the salt kind of bouncing around everywhere? Whoa, goes everywhere, right? So this happens because of the vibrations. When I tap the tuning fork on the table, it causes the tuning fork to vibrate. And then when those vibrations touch the plastic wrap, we see the plastic wrap also, oh my goodness. We see the plastic wrap also vibrate, and oh, there we go. I thought I lost you. And the salt kind of jumps around or dances. And I just made a big mess of salt everywhere. Go figure, right? Okay, so that was exploring vibrations. Our next one says we're going to take a ruler. We're going to let 8 centimeters hang over the edge of the table. Then we're going to hold the table end of the ruler and push down with the other hand and let it go. So we're going to look at the vibrations that we see and listen for what we hear. And then we're going to repeat that at 15 centimeters. So here's 8 centimeters. I'm going to hold it. And here's 15 centimeters. So here's what I noticed. I noticed when there were 8 centimeters hanging off, there was only a little bit. It was very small, kind of like the small tuning fork. So the vibrations were much faster, and that caused the pitch to be higher. When I had more of it hanging off the table at 15 inches, it was kind of like the big tuning fork. The vibrations were much slower, which caused a lower pitch. I'll do it one more time so you can notice the vibrations and the pitch. Here's 8 centimeters, and here's 15 centimeters. Do you hear the difference in pitch according to the vibrations? All right, the next thing we're going to do, we already did this. It says touch the center of your neck and say something. And then it asks, what do you feel? So then I would write, when I touch my neck and talk, I feel the vibrations of my vocal cords. All right. The next one says, we're going to have an index card and a comb. It says, move the index card across the comb slowly, then move it quickly. Describe the differences in what you hear. Which one made a high-pitched sound? Which one made a low-pitched sound? So I'm going to do it slowly first. And then I'm going to do it quickly. Do you hear the differences in pitch? The slow vibrations made a much lower pitch sound. The fast vibrations made a much higher pitch sound. All right, station number 5, we have 2 bottles. One is empty, one is full. I'm going to blow into the bottle that is full first, and then the bottle that is empty. So here's the one that's full. Hopefully I can do this. Ooh, did you hear that? This is tricky. You can kind of hear it a little bit. And here's the one that's empty. Whoa, I definitely heard that one. So I think I heard the one that is full made a higher pitch sound. The one that is empty made a lower pitch sound. Let me see if I can get more sound out of this full one. This is hard. There we go. Woo, that's tricky. That's a high pitch sound. Here's a low pitch sound. Woo, all right. Goodness. And then the last one is a thick rubber band and a thin rubber band. We're going to stretch the thick rubber band between our thumb and pointer finger and pull it. I hope you can hear this. That was the thick one. Here's the thin one. That's hard. Listen again. See if you can figure out which one has a low pitch and a high pitch. Oh, I heard it that time. There we go. So the thicker rubber band made a lower pitch sound because it vibrates slower. The thinner rubber band made the thicker one made a lower pitch sound. The thinner one made a higher pitch sound. There we go. Ooh, Miss Seals is getting confused. So those are our little exploration stations for learning about sound, energy, and exploring vibrations and pitch. If you would like to do any of those at home, they're all pretty simple. The only one you probably wouldn't be able to do is the first one with the tuning fork, simply because you don't have those. But if you have a ruler, a comb, an index card, 2 bottles, and 2 rubber bands, then you should be able to do the rest of these exploration stations. If you do these, if you would like to send me a picture or a video, I would love to see you doing some of these explorations. That would be awesome. Remember that Science Lab is not required, but it is, extra, help you kind of learn these science concepts. There is a short quiz after this video. Do your best. I hope that you guys had fun exploring sound, and I will see you next week when we talk about another form of energy. Have a good day. Bye, guys.